How can high-tech greenhouses make it possible to grow tomatoes in the deserts?
But like a lower tech kind of greenhouse or kind of net house or whatever would use anywhere between 250 to 300 liters of water per kilogram of produce. We are a much lower level. We're around 20 liters. We can go even further lower as well. So we're 1/10, if not even less, of the water consumption of what a traditional farm is.
And how can climate technology help make our food systems more sustainable and resilient?
Technology plays a vital role in building resilient food systems. While technology today is widely spread in more advanced countries, we need to reach a point where technology is everywhere in order to reduce those massive 30-40% of food that is wasted.
That was Majed Halawi, Vice President of Engineering and Construction at Pure Harvest Smart Farms, and Raluca Radu, Portfolio Leader of Services and Solutions at Thermo King. You'll hear more from them later, alongside other special guests. I'm Dominique Silva, and you're listening to Healthy Spaces, the podcast exploring how technology and innovation are transforming the spaces where we live, work, and play. In this week's episode, we'll hear from Majed about the innovative approaches to growing food, regardless of the local climate. We'll also hear from Adnan Javed at Trane about the technologies that are helping to make indoor farming not only possible, but more sustainable. And finally, we'll learn from Merluca and Ntupiu at Thermo King about how the food transportation sector is making big strides, both in decarbonization as well as telematics, all in order to help reduce food loss and greenhouse gas emissions. To start off, we're transporting ourselves to the United Arab Emirates, a desert country with very limited natural agricultural resources, which therefore needs to import at least 90% of its food. To ensure access to food, especially in times of crisis, the UAE government has carried out several efforts to improve food security, starting with a boost in local food production. But given that 80% of the UAE is essentially a desert, growing fresh produce seems almost impossible. My first guest today is Majed Halawi, Vice President of Engineering and Construction at Pure Harvest Smart Farms. He explains how companies like Pure Harvest are making what seems impossible possible.
Pure Harvest Smart Farms is essentially a technology-enabled agricultural producer. What we do is we design, build, and operate high-tech facilities or high-tech farms, greenhouses, which allows us to produce fruits and vegetables locally, so in the regions that we operate, to do that year-round and be able to sell very high-quality produce into the local market at a reduced price of comparable quality imports, right? So the way to think about us is essentially in our markets, which is predominantly the Middle East and Southeast Asia, we are able to produce locally and leverage, whatever is available within the local climate to be able to produce things like tomatoes, berries, capsicums, cucumbers. We're even now doing melons. And all that with the use of technology, but ultimately to allow the crops to reach their full potential and be able to do that in a cost-effective manner.
So how do these high-tech greenhouses differ from traditional greenhouses that we're all used to seeing? Do they turn out to be more cost-effective?
Like with any sort of type of technology, right, there's different generations of degrees of sophistication that exist. Ultimately, what we do and the technology that we use is it is still a greenhouse, right? It's a controlled environment agriculture where you're providing shelter for the crop. However, the secret sauce here is the extent in which we are able to control all the factors that occur within that greenhouse. We control things from the temperature to the humidity to the air movement to the carbon dioxide levels to all the kind of control sensors you can ever imagine within the facility. So this is considered kind of the highest level of technology that exists within the greenhouse space. Some people think of, for example, vertical farms, which, like kind of a closed kind of environment. So a lot of the same principles exist, except we use natural light, whereas, a lot of vertical farms use LED lights. And so, given the markets that we're in, we believe that natural light can be a very good and free resource, essentially, of energy into our facilities, right? So we've customized that solution to be able to do that in a very efficient manner. And, you might think, well, that sounds really expensive. Well, yes, it is. But then the output of that is also very, very high. It's a high cost to deploy, but it's a very high output. And so we've been quite economic in that sense.
So you've touched on the very important subject of water. And traditional agriculture is known to be extremely water demanding. In fact, I've read some reports saying that irrigation used for agriculture accounts for 70% of fresh water use. And yet, Majed, here you are talking to us about harvesting tomatoes, berries, cucumbers, and lettuce in one of the most water-scarce regions of the world. So, in your view, how can technology-enabled agriculture or highly controlled environments ease the food-water nexus?
The important thing to note is, what does agriculture use the water for, right? Now, irrigation is one thing. There's also irrigation runoff, where ultimately the plant needs only as much as it needs to basically fruit and to vegetate, but then everything else kind of gets run off. Then you also have water that's needed for cooling, humidify the air or do something so that you can cool out the plant, etc. And there's a lot of other activities where water is effectively wasted, right? Now, what we do is, given that we can grow in a controlled environment, a lot of the water that you are going to be using gets captured and then gets recirculated. So the plant only takes what the plant needs. All other water is then drained and then recaptured, treated, and recirculated. So we can dramatically reduce the water that we use. And also because of the way that we grow, we don't need to use as much water for cooling as with other growers. The way that we benchmark it is the traditional farm, which is not even the lowest tech farm, of where just open field agriculture, but like a lower tech kind of greenhouse or kind of net house or whatever, would use anywhere between 250 to 300 liters of water per kilogram of produce. So think about that, right? 300, right? Think about how that 1 liter of water that you drink, or 2 liters per day that the doctor recommends, 300 of those. We are a much lower level. We're around 20 liters. We can go even further lower as well, but that's roughly, so we're 1/10, if not even less, of the water consumption of what a traditional farm is, right? So we can dramatically reduce the water demand on this. And then the reality is that the Middle East, yes, it's water scarce, but there is plenty of water if it's used wisely. And so this is where we position ourselves. And then also more importantly is that we're using a lot less water, and we're creating kind of economic output as well, a lot higher economic output, because given the value of the products that we're able to grow.
So, improving crop yields, growing food closer to the communities that will consume it, and at the end of the day, using less natural resources to do so, it really sounds like a win-win-win. So, what's next for Pure Harvest Smart Farms?
So there's a lot that can be done. One is pure just growth, footprint of productive capacity, right? So hopefully this year we're going to be launching an Asian operation. So we're looking at building a farm in Singapore, and that will be kind of a little bit of a lighthouse for us into the Asian market. So that's a big milestone that we're aiming to achieve there. And so then expanding our footprint as an organization. That's number one. Number two is diversifying the crop portfolio. We're constantly trialing new things and kind of saying, what else can we grow? And then finally, which is probably the most exciting, is anything related towards autonomous growing, right? So autonomous growing is effectively the ability for us to be able to grow our food with as little as possible human intervention, or ideally no human intervention whatsoever, right? Now, still a ways away, which requires a lot of data capture on the plants themselves, understanding how the plants are performing under different climatic conditions, being able to scout the plants, identify things like flowers and fruits and whatnot, having all that data available, and then to eventually get to that point. So the whole industry is very much in the early stages of that, but that will be kind of the next step of that, which one is kind of reducing the human error. There's ways that you can kind of monitor, quality of maintenance of the crop and etc. But also reduce the need for, these super seasoned, experienced horticultural experts to kind of be everywhere, right? And then you can capture their mind on a computer and then help the computer run this, and then have them just kind of check in on these systems, right? So that's kind of the long-term vision.
We just heard from Majed about how tech-enabled agriculture is helping countries like the UAE to improve food security in a climate-friendly way. But such innovations aren't limited to desert countries. All over the world, from Tokyo to Sao Paulo, the practice of indoor farming is spreading rapidly. And with it, so are advancements in technology that help create these precision-controlled environments. My next guest is Adnan Javid, General Manager at Trane Middle East and Africa. Adnan, maybe you can start us off by explaining what these tech-enabled greenhouses actually look like. What kind of challenges are you dealing with?
So the plants during the day, during the photosynthesis process, you need to have CO2 in a certain quantity, right? So you have chillers on one end provided by Trane, and then the chilled water is going to the big blowers, right? Now, the CO2 sensors are all over that facility. So now the CO2 sensors have to speak to the control system wherever there is some variation, right? So, which means the temperature coming out of the chiller has to adjust according to the need. And that's where our control offering, we use our controllers where the signal can go very quickly right back at the equipment. So there is a consistent CO2 environment that is created during the photosynthesis process. For that, you need to have ability to run two things very effectively. One is your chiller should be able to change the water settings very quickly. And then second is the ability to have the right controls where this message can go to and fro very quickly. And that's where the controller and the chiller work hand in hand. So there is enough amount always there.
So essentially, we have these high efficiency chillers, which are coupled with sophisticated control systems that are continuously monitoring and adjusting indoor environmental quality factors. And that includes temperature, humidity, and carbon dioxide levels. That's really interesting.
So that's one side of the story, right? So that's during the day. Now let's think about what's going to happen at night. So at night, you need humidity control because the outdoor temperature changes. So then you have a lot of focus to have a certain amount of humidity because they grow in a humid environment, right? So that's the environment around them. Then they need to have the need of heating, right? And that's where the heating and cooling story becomes so important. And that's where our role becomes very critical. So then the question is, how do you provide that humid environment to these plants? So for that, we have heat pumps, which are essentially devices that can generate hot water and cold water at the same time for people who may not know what exactly is a heat pump. So why it is so efficient? Because in this case, the product that we are delivering at the customer site is hot water. Now, the byproduct, which you can also take it as a wasted energy, would be the cold water. So while these equipment of ours are providing hot water, they are using the byproduct, which is the cold water, and that is being stored in a thermal storage battery. So that's why not only we are providing a solution, but it is also a very optimized solution where we are not wasting any energy. So you're almost at 100% utilization mode, right? So there is no wastage that goes out of this.
Now, let's turn to the next step in what can be a very complex food supply chain, and that's getting fresh produce from the farm all the way to the consumer. Did you know that approximately 1/3 of the food produced is either lost or wasted? And that the biggest portion of that is actually fruits and vegetables, which are also so essential for a healthy diet? The cold chain plays a critical role in reducing food loss all along the supply chain. To tell us why, here's M2 Pugh, Vice President of Strategic Marketing at Thermo King Americas.
So Thermo King makes a portfolio of what we call transportation refrigeration units, or TRUs. We don't make the truck, but we make the truck cold. And so it's a really, really important innovation for ensuring the quality of food from the point where it gets harvested to the point where it gets on your shelf at the local supermarket. So It's a really, really important part of the food chain. There's a large, frankly, unacceptable chunk of food that is wasted somewhere during that process. So what gets me excited is, one, we've got a set of folks here at Thermo King who are always focused on how do we make it more efficient, how do we have more range, and frankly, how do we make it more reliable? And so one of the causes for food loss during this process, frankly, is downtime of the machine. And so our focus really is around making sure that our units stay up and stay operational and stay performing on a wide range of different products. The second piece, and this is around the changing of the supply chain, right? A big part of our business is what we call sort of full trailers. And so if I've got a 53-foot trailer and it's full of meat or seafood or frozen vegetables going from California to Chicago, that's a big piece of our business. The smaller pieces of our business are growing faster, as in those hub and spoke routes, as we call them. So the routes from a local farm to a local supermarket that don't necessarily take a 53-foot tractor and trailer, but they take a 20-foot truck or a van. Those routes, frankly, are, I think, slowly but surely reshaping the food supply chain to make it more dependent on those smaller vehicles and smaller routes and less dependent on those bigger vehicles and longer routes.
So M2, it's clear now that transport refrigeration plays a critical role in minimizing food loss. Unfortunately, it is also carbon intensive. We hear the word decarbonization thrown around a lot, and I'd love to know what it means to you as well as to the transport refrigeration industry.
I spend a disproportionate amount of my time working with our engineering team and our dealer team and our commercial team and our product management team, talking and thinking about decarbonization as it relates to the transportation refrigeration industry. So it's a subject that is near and dear to my heart. I think about decarbonization as the process for removing greenhouse gas emissions from our products and from our customers' products as they ship food around the country and around the world. And so it's important here to recognize that decarbonization is not binary. And so decarbonization is a process that lessens the greenhouse gas emissions over time.
I see. So electrification, which means transitioning from fossil fuel-based engines to all-electric TRUs, is really a big part of that decarbonization journey. And I'm sure we're going to talk about it later. But let's talk about other technologies which are also shaking the industry, like big data and AI. How do you see these technologies helping the food transportation sector?
We have known for a while that data and information were really important. It is becoming more and more important. So as we talk to our large customers, almost all of them are saying, I need more information to help me manage my fleet better, to help me reduce my expenses better. In the next few years, when we get to an electrified future and other means of decarbonization, that takes on a complete other dimension that says, help me manage energy better. And so I think it's a huge opportunity for AI and machine learning and those kind of things, right? Because now I have to think about when to charge my units and what routes do I have now, not necessarily based on the driver that I have or the product that I have. Those things are still important. And the fleet that I have or the exact unit that I have and whether it's charged or not, or what my infrastructure needs will be on that route or not. So it's a whole different category that I need to bring into effect. And that is enabled and improved by AI and machine learning and those kind of technologies. And so we are building what we would call tech-enabled products that frankly can plug and play into those kinds of learning technologies to make the total ecosystem more efficient as opposed to just focusing on the product. So I think you're right on that that's going to be absolutely critical going forward.
Decarbonization efforts and government focus on boosting local food production will help reduce our food's carbon footprint. But how will this impact the cold supply chain? What opportunities lie ahead? To explain this and more, here is Raluca Radu, Portfolio Leader of Services and Solutions at Thermo King Europe.
The last mile delivery will become even more predominant. And this last mile delivery comes with some challenges, let's say. There might be some resistance to this trend because both noise and air pollution can reach quite high limits, right? So if now all the trucks will need to go in the center of the city and deliver their goods there, that comes with some, let's say, potential disadvantages. Nevertheless, here also technology plays a role to eliminate these roadblocks and make this more, let's say, human friendly. Imagine that you live in the center, you're in the center of Lisbon, and at 4 a.m., out of the sudden, you hear a truck, and you go there outside, and you see a truck delivering fresh strawberries to your supermarket. But you are very annoyed because the noise really woke you up. So this is a serious issue. And we see that more and more countries are regulating the noise level in urban areas. How technology can facilitate this? Basically, our cooling units, again, automatically recognize when they are entering in these low noise areas and automatically change their operating mode from high speed to low speed in order to reduce the noise level. And because they are equipped with this telematics, they can recognize the units where the truck is and send an automatic command to the unit. So there is no human intervention, and it's similar with the air pollution area, so the LEZ zones. Your unit can detect when it is in an LEZ zone, and then it changes from diesel to electric. So such technology advancements facilitate the speed of this centralized food delivery or food urban farming, and implicitly encourages growing this food closer to the population. Otherwise, these roadblocks might only prohibit us from going into this direction.
It's so interesting that you brought that up, Raluca. I mean, after all, this is the Healthy Spaces podcast, right? And we've been talking extensively about how we create environments that are healthy and productive for people. And you just brought up something that people don't often associate to, but it's the fact that an increase in last mile delivery and more trucks coming in to distribute more food, if not done correctly, can indeed lead to higher levels of outdoor pollution and noise. And that is a great segue into another big topic, which is the electrification of transport. So in your view, Raluca, how realistic is that?
Figures show that by 2030, we will have around 50 to 55 VP units. The VP units are the small ones, are going to be fitted on electric vehicles. So all the small vans, majority of them will be electric. We also know that around 30% of the trailers will be electric. So I think electrification is here. It's something that we cannot omit anymore. We see that this is coming a lot from the environment. There are more and more regulations. Then there is the carbon footprint. Again, a lot of regulation, a lot of targets about carbon footprint. All of these are forces that will influence the adoption of electrification. And we see also in our industry, so all our units, we see there that more of those are electric. So I think when you look on electrification, you need to have an electric means of transportation, so commercial vehicle. And there we see more and more in this direction. Once you have an electric vehicle, you need to have an electric unit. And electric refrigerated units are coming more and more. But let's say you have the commercial vehicle, then you have your electric refrigerated unit. And this refrigerated unit needs to take the power from somewhere. So then you also have a power source. And then, very important, all the data about that battery needs to be displayed somewhere. So we are proud, let's say, with our Tracking E, which is the dashboard that gives you all the insights that you need in order to monitor the status of your battery, but also to be alerted if there are any issues with the battery state of health, for example, and also allows you remotely to control your power source. When it comes to the power source, we are proud of our new entry, let's say, in this space, which is the Excel-powered product. It's a technology that you can recuperate the energy from the axle movement of the trailer. And that energy is captured and stored in our energy pack battery, and then can be used to power the refrigeration unit. So imagine there, if we are talking about waste, what a great technology.
Of course. And I mean, connecting this to our previous discussion about last mile delivery, right? And more smaller trucks delivering food. I mean, when they're operating in these urban environments, there's going to be a lot of start and stopping. I think, having a technology that is able to recuperate that energy and then reuse it, it's fantastic. Thank you for sharing that with us, Raluca. I'm ready for my last question, Raluca. Are you?
Let's see.
All right. I'm going to appeal to your imagination and I'm going to create a scenario. All right. COP28 is being held in Dubai. You have been invited as an expert in this field to attend, and you are suddenly informed that all of the world leaders are in one of the conference rooms. They were waiting for this big presentation. Someone taps you on the shoulder and says, Raluca, we need you. They push you onto the stage. You are now faced with all of these world leaders, and you have less than 2 minutes to take your spotlight and tell them what you have to tell them. So you're on the stage, Raluca. What do you have to say to our world leaders?
I think what I would say is that technology plays a vital role in building resilient food systems. While technology today is widely spread in more advanced countries, we need to reach a point where technology is everywhere in order to reduce those massive 30-40% of food that it's wasted. And in my view, there should be 3 areas of focus. First of all, is to raise awareness around how technology can impact the food system, from growing food, harvesting food, to transporting food. Secondly, is to promote technology, to make it an ally in this food waste, food loss journey. And third, which I think is highly, highly important, is to make technology accessible to everybody by subsidizing, for example, the access to technology. I can give you just 2 examples. One is from Italy, where they have an Industria 4.0 program, where the Italian government subsidizes the equipped refrigerated units with telematics device, under the condition that this device can remotely control the temperature inside the box. So the Italian government gives money to all these companies that are investing in making sure that if something happens inside the box, they can control the temperature, hence reduce the food spoilage. And similarly, there is a regulation or a subsidy like this in Germany, where the usage of telematics device is encouraged by the government and subsidized. So this would be my message. Promote, raise awareness, and make technology accessible, because it can only contribute to reducing the spoilage that we are all concerned about.
A big thank you to Majed, Adnan, M2, and Raluca for joining me on today's episode to discuss the technologies and innovation transforming how we grow and move food. And thank you for listening. If you want to find out more information on our conversation today, make sure you check out the show notes. And remember to rate and review Healthy Spaces in your favorite podcast app. Join us next time when we'll be finding out how to build more resilient healthcare systems.